What we see when we look at stainless steel is just a function of the light frequencies that is reflected back from the surface. So this means that the light source, whether it's the sun, your LED light, your candle, is important. The surface size, there's a vast difference between a full sheet in the sun, comparing that to the same surface finish, business card size under electric light. And then also the surface condition of the material. Those three things are the key factors. So when we do look at customer specification, usually in the title block of the drawing, there's a bit of fine print specifying some sort of RA surface roughness figure. But this alone is not sufficient to fully specify the mechanical finish on stainless steel. The RA values might be the same, but the visual effect might be different. And in practicalities, if we think about it, how many people, how many fabricators have got the ability to measure RA values, and how many of these guys specifying it can actually measure it when they receive it? When the aim is to precisely match the specified finish to that you can deliver, the best approach is to use comparative surface finish samples or swatch samples. So this is important, a visual benchmark. So what you will do is figure out what the surface finish is required, You will give it your best effort that you know that you can repeat in your fabrication setup. And then you will get the approval from your customer. Once that approval is there, you can give, either side can have a sample of this finish that they use in the quality departments. It saves a lot of headaches. So when we go further than the RA value, determining the mechanical process for getting to this finish, it's important to determine the grit size of the abrasive. But this is only a first step, because our finishing, you will see later on, there's quite a few steps attaining the correct finish. So it's only, the grit size is also only a part of a specification process. So just like an RA value, to tell somebody to finish at 180 grit is also not completely sufficient. So when we talk about grit size and specifications, this is normally the grit sizes that we will work at for different processes. So the removal of weld seams, that will be around 40 grit. And when we do the hot rolled material, 2B finish with that orange peel effect, we will also start around about a 40, and we move up to a 60 grit. The cold rolled material, you can start at 120 grit. If needs be, you can go down to 80. And then as you go through your finishing steps towards a final, very fine finish, you will use 120 up to 240 grit. And your final polishing stages will be up to 400, even in some cases up to 600 grit. So the choice of grade of material, this is a good one to remember, is also important when you want a very, very smooth or highly reflected polished finish. The chemical composition is important here, especially on tubular products. Many of these grades are alloyed with some titanium, like grade 321 and 316Ti. And this gives the material excellent resistance to intergranular corrosion, but when you finish it to a high degree, it leaves a streaky or an uneven look to it. That, you know, you learn that quickly once you've tried to do a finish. I think there's a lot of people that have burnt their fingers that way listening today. Okay, so let us have a look at the finishing methods. Let's kick off with grinding and polishing. This is a mechanical method of removing layers of material from the surface with an abrading action. So it involves hard particles that's glued or bonded on a backing, and this then moves at speed and at a specific pressure to remove the upper surfaces or the top surfaces of the material. Now, grinding usually refers to the removal of surface finish, such as weld seams and oxide layers, and is in most cases regarded as the more aggressive removal. Polishing is more for decorative work, where the surface is also intentionally removed, but less aggressively so. Now, after we've got that nice polished finish, then we can shine it up even more by buffing. Now, buffing is not a process intended to deliberately remove material from the surface, but rather a smoothing process, just making the material more bright. Now, you will know it well, the cloth wheels that is used as indicated there on the picture. Now, the process can involve, it will involve the use of pastes and liquids and even solid buffing compounds of different abrasive values. We also call it soaps. That's rubbed or applied to the cloth wheel, and then it enhances the finish. And the fine finish, the finish is produced dependent on the pre-buffing stage. So you can't just take the buff wheel and put it on mill finish or hot rolled mill finish. It will only shine the dimples up, basically. Buffing can be done in single stages or multiple stages, and then with different grid sizes. And it's usually in stages, and the direction of each stage will differ from the previous. We'll look at that later. And this is a type of finish that is usually used by pharmaceutical companies. It's that type of specification and some architectural products. Now, brushing is sometimes also confused with polishing, but it's different things. You'll remember that polishing is removing or less aggressively than grinding, but it's removing material. Brushing is not intended to do that, but it's also an abrasive finishing process. Milder abrasives are usually used to only texture the material. So it changes the surface conditions so that we see light deflected or reflected in a different way. So typically it will be a brush finish as indicated on the picture. So there we use wire brushes and Scotch-Brite items, belts, pads, and wheels. But once again, it's very important to use representative surface finish samples when specifying the brush finishes. Your wire brushing might not look like mine, and so we once again we need to negotiate this and make sure that we've got the visual aids to assist us when doing the job. Right. So what's important normally when we talk about the final appearance and the quality of the surface? So I would say the surface quality is more important than the appearance, but the two go hand in hand. It's dependent on your abrasive type. Now, your backing material is very important because that gives you more or less flexibility, the removal of heat, things like that. Your grit size, your shape, and your hardness is important. Then also the number of finishing steps. Like I've mentioned, you can't go from a 2B to a mirror finish in one go. Then also the equipment and its power supply. We will talk about the power supply just now. And how the abrasive is supported, coming back to the backing type. If it's a belt or a disc, what is the flexibility? Then obviously, and this is where the operator's skill also comes in. There's a surface speed and an applied pressure. And we need to control both of these things very carefully to have optimum lifespan of our equipment and our abrasives, as well as getting efficiently to the required surface finish. The optimum choice of finishing equipment, the consumables, and the method that we're going to use will depend on what is the existing surface finish. If it's really close to the final finish, then obviously you will go for faster equipment, less pressure, finer grit sizes, etc. The accessibility of the areas are important, especially when it gets to your tooling. and then what the final visual effect must be. Now, all the brands available in the market has product-specific methodology and tooling. So, you know, these abrasives are made for specific pressures, specific speeds. So please talk to your supplier regarding these optimal parameters. It's well worth it. You will, all attendees of today's discussion will receive a document on which this presentation is based, and we will also send you a list of the current members that's active in the abrasive and polishing and finishing world. If we look at then at some of the equipment we use, or the consumables we use, there's the abrasives belts. We all know them, different sizes, widths, grid sizes, backings, and you can even get them to custom-made lengths to suit your equipment. This is a very handy thing in your workshop. But then another abrasive effect, which is not as aggressive as the abrasive belts, is your Scotch-Brite and similar product range. We use this especially for blending in material, and these things are not, well, you can also get them in belts, wheels, but we use them a lot in manual operations in pad form. And they're not graded in terms of grit. They just called coarse, medium, fine, very fine, super fine. This is the standard workhorses in our industry, the flap discs. And this is usually used in the initial stages where you want high volumes of surface material to be removed. These things are a bit aggressive and they can bite. So for a little bit finer operations, you will use the fiber discs, also known as sanding discs, or here in the Boland as papiertjies. It's less aggressive than flap discs and less prone to undercutting. But when you need to remove material, this is not as cost effective as the flap discs. There's also the unitized wheels. This is a Scotch-Brite looking type material. It's a nylon type of bonded material. We put it on mobile or portable machines, and you get them in various diameters, and you get different densities and flexibilities. These things last pretty long, and they're able to give you a uniform finish from the first action right until the consumable is finished. And it's especially popular where you've got long welds where you just quickly want to strip clean your welds and the heat-tinted metal. Convolute wheels, very similar to this, but it's just formed by wrapping layers of abrasive around a hard core to make up a wheel. These things are less flexible, but also less aggressive. So, but for both of them, because they've got a small contact surface, please be careful with your speeds and pressures that you apply. We will have a look at some of the popular tools, and the first lot is the fixed tools. And on this combination picture, you will see the old workhorse there in the middle, the fixed belt grinder, suitable for deburring things and sharpening drill bits and all kinds of general work. There's the flexi polisher. It looks like a Dremel tool on steroids there at the front, at the bottom. So it's a fixed machine, but it's got a flexible shaft, and you can do quite arduous in-shop polishing work with it. Then on the right, there's the long spindle buffing mills. There you can put on there anything from a stone to a grinding stone to cloth wheels. Also, you will find one of these things in all stainless steel shops. Then you will also see where they do a lot of tubing, the tube notching machine, and it's used to prepare joints for pipe intersections, etc. Right, this is where we get to the portable tools, and these things are the workhorses of the industry. So the first one there that you see is a portable grinder. You don't see them that often, but they're multi-purpose tools and you can use them on plate as well as tube. You can put all kinds of easy to change abrasives on there. That one has got Scotch-Brite on, but you can even put an inflatable wheel to give you different hardnesses and flexibility of your abrasives. Keeping the speed down on this guy because it's quite aggressive. Can avoid excessive heating. You see it's quite wide as well, and it will limit surface damage. So your pressure and your speed should be in good balance, but low speeds. You get the old angle grinder. This is a very popular tool, DIY and in industry, and you know how they work. They work on flexible abrasive discs. Usually these things are very versatile with all kinds of things that can be fitted to it, and it's good for both grinding and polishing. This is a handy tool, also not that often that you see them. The internal angle finishing tool for cabinets and things like that to remove weld marks. So this is a very thin disc, and it's also versatile for grinding and polishing. Tube polisher, this is a very efficient tool, and the main feature is that it's got a belt on that is mounted on flexible wheels or the physical mounting is flexible, so that you're able to wrap the abrasive close to 270 degrees around your tube. So for blending in and finishing off tubes, very, very efficient. Very similar to that is the Powerfile, so it's just narrow. It's a pneumatic tool, and it's good for deburring and grinding off weld seams, but it can give uneven surfaces. It's fairly aggressive. It bites. Right, so if we look, hopefully you can see this, but this table will also be in your documentation. This is sort of just an explanation of the different power supplies, the advantages and the disadvantages. But from my experience, and I think you will agree, the most popular tools are the portable electrical ones. And the reasons for that is basically that you can work on readily available single phase power. It's generally fairly cheap equipment, easy to use, versatile and mobile. The drawback on the pneumatics is the higher energy cost. Obviously, you will have to fork out some money to get your compressors and your air lines in, and then your tooling is also a bit more expensive, and then you sit with very high noise levels. But they're efficient. The electrical or the stationary machines, the fixed ones with flexible shafts, the limited shaft length can reduce your accessibility, and then a high level of operator skill is also needed here, and we don't always have that. Okay, so now we get to the stainless steel part of things. Best practices when we work with stainless steel. Now, the best way of saving cost and time in your finishing department is by minimizing the finishing. So it's important to purchase material that's in a good condition and as close to that final finish as you can get it. So it's usually very good to negotiate with your supplier or with your customer to accept the standard mold finish. Protect these high value finished components throughout all stages of manufacture and storage. And this is where one of those courses of ours, the shop floor courses, can assist your storage and your storeroom people. Then also the correct welding procedures and equipment is important. When it comes to high quality finishes, the TIG welding method is unbeatable. But remember, TIG welding is slower than MIG or stick. So you might save on the polishing, but you will spend more time on the welding. So once again, it's a cost decision that you've got to make, how you will balance it. And then obviously avoid excessively thick weld seams. Not only is it going to take long welding those things, but it's obsolete material that needs to be removed. a bit of an example how we can select finishing methods appropriate to the design, or then the other way around, design to fit or to make it easier to finish. On the left, we've got sort of what's called a soft tube joint, where we use a standard preformed elbow that we cut at the right angle, and then only 2 straight joints are needed. It's good access for both welding and finishing. On the right, there's the miter joint. It's a sharp angle, and therefore your accessibility to the inside for welding and cleaning off is restricted. In both cases, you will finish it off manually with a Scotch-Brite type of consumable. Okay, so for industrial finishes, it's usually the weld areas and so on that gets finishes, and corners gets deburred. But when we are talking about decorative finishes or hygienic finishes, some precautions must be kept in mind. You must keep your surface dressing to a minimum. Every little nick or bump or heat distortion will reflect the light in a different way, and it will always be visible whether you polish it or not. Avoid a localized heating. Work with existing polished or the existing grid and direction that's on your material as you buy it. So keep your heat input as low as possible, not only in your welding process, but also in your finishing process. Once again, a function of speed and pressure. Increasing your tool speed and pressure, well, if you increase that, then obviously you will get the job done quicker, but you will have a high turnaround in tools, and also your cost in consumables will escalate. And when you change your grid sizes from 180 grid to 240 or whatever might be the case, clean off the workpiece, blow it out with air and the equipment to make sure that all those large grid particles are gone. And when you blend it in, keep the same polish direction all the time through all the stages. And when you do the hand polishing, use a long stroke in the final stages. So if you've got to start and blend in a piece of material, then we must be very careful not to go for too rough a grid size. So rather start off with one that might be too fine, rather than one that is too coarse. The choice of the successive abrasive grid sizes to get to that final finish is also very important. So we would normally try and not exceed sort of twice the grid value. So if you started off with the 80, don't go higher than a 160 with the next stage. When buffing, then we change, as I mentioned earlier, then we change the direction between every step or of the process. 90 degrees, this gives a better reflectability or a reflection of light, so the material appears brighter. So, but like in any stainless steel shop, whether it's industrial, architectural, or for high-spec industry, good housekeeping during storage, fabrication, finishing, and installation is extremely important. So the laser film, that PVC coating on your sheet metal to protect the surfaces, it's important. Keep those coatings on as long as possible. Try and get your tubular deliveries, your square tubing, your pipes and so on in plastic sleeves. Please do not, and it's such a simple thing, but we still see it quite often, keep your abrasives segregated. Do not mix abrasives that was used on mild steel at all. If possible, you must separate your storage areas and if possible also your working areas, even if it's just a curtain type of divider, just to make sure that dust does not float around. Dust is our main enemy in the fabrication areas. And there, once again, punting that course of hours care must be taken during storage and handling to avoid damage and contamination. And I think we underestimate the amount of damage to material during storage and handling. When we use lifting equipment, you might use a dog clamp on mild steel equipment. You can't use it on stainless steel equipment. You usually got to protect and put some sort of non-metallic uh, uh, something, card box or something in between when lifting stainless steel with mild steel equipment. Work tables normally also designed to facilitate the work on stainless steel, so it will clad with a thin inert layer, wooden layer, hardboard, cardboard, something like that. And the old thing that still happens even in our best facilities: do not walk on stainless steel sheets. And then obviously, right at the end of it, our packaging materials and methods must help us to prevent any surface damage during transport and delivery. The same care must be given during installation work, obviously. Okay, safety also remains an issue, and I don't think I have to tell you any more about it, except to inform you that, remember, there's moving and rotating parts, and these parts are covered with abrasive material. These abrasives are also sometimes prone to fragment and fly all about the whole place. So safety glasses, that type of thing is important. And then once again, the dust and grinding fragments. Please clean your workshops and make sure that that dust is extracted. There's vibration, and you've got to be aware that especially the pneumatic tools are quite noisy, and these things create heat. So finally, so that you can go on with your rest of your day, let's have a quick look at how this double basin sink unit was made for the catering industry, and how they use this knowledge in the previous sections to limit damage. So there you will see the frame has already been made, welded, and some of the sheet metal components on. It's all protected with the PVC coating, and that recess, then the two holes in the top must be very carefully cut for minimum burring. In the old days, they used to do it with nibblers, and then they had to deburr. Nowadays, that's why we've got laser cutting and NC methods of doing things. Even the bending is very important. So once we put the drop-in bowl in, there will be a good joint to render good welds that will require only minimum material to be deposited during the welding process, and then it can be easily cleaned off to the correct hygiene standard. And there at the bottom you see a punching machine. The PVC remains on as long as possible. On the bending side, the top tool does not create a lot of damage. It's actually the two lines made by the V block at the bottom. So you will keep your PVC at the bottom. There's also a strip that you can put on your V block. We used to call it the bending condom, that you can put on there to protect the material against any friction or abrasion there. As you can see at the guillotine, they do the same thing. The PVC remains on. The bought out parts, components, those bowls, pre-made legs and members for the tables, they're all stored properly and dry, and you can see they're on wood there, so they don't scrape against the carbon steel shelving. Look at the storage, used trolleys. Those things are all PVC coated, completely stored upright. You see there's barriers next to the tubular products as well. It's protected and safe. So now once they drop the bowl in, the PVC will be removed in the area where we will want to weld. Your artisan, his workmanship comes in now. They will have all kinds of custom-made clamps and things to get a proper fit. They will then start, and this is where the correct procedure for welding comes in. They will start to tack weld this in, but small tack welds, but with lots of them to minimize distortion, and then it will be welded up to smooth these tacks down. They will also use copper bars, backing bars, aluminium backing bars to extract heat from that weld zone to minimize the heat input, as we discussed. So then once it's welded, the area can then be smoothed down through grinding, and then it can be finished to a high standard of corrosion resistance and the hygiene requirement with usually then papiertjie or the sanding discs. And then with smaller rotating tools, you can get the round, the radius on the top, and you can get it nice and smooth. The final action is a manual action with the Scotch-Brite pad just to blend the surfaces and the different finishes in. The same applies for the press brake work. And now this starts at designing already. The component will be cut with bend relief recess in the corner so that you get a perfect fit up of the two little flanges. These things will then also be tacked lightly and then as close as possible to autogeneous weld, the one without filler material. These things, the corner would be fused and then worked off and blended into the correct specification, and the PVC will be put back. So right, there you've got your finished product, and after removing the heat tint at the bottom, this piece of stainless steel is quite valuable, not only because it's complete stainless steel, and stainless steel is valuable, but of the skills and workmanship that was put in there. So it's only proper now to protect it even further after the pickling or the passivation process, wrapping it, packaging it properly, and storing, delivering, and transporting it correctly.